Hey y'all, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is a worksheet on finding trigonometric ratios. So we're just trying to so ratio a lot of times can be said, but then what they actually mean is like a fraction or even sometimes a decimal. Fractions, decimals, percents, ratios, they sometimes use those interchangeably. But yeah, so that's what they're talking about here. They really mean like a fraction, and a fraction is probably going to be the best way to do it. And that's probably the way your teacher's looking for you to write it. I'll write it as a ratio and as a fraction, at least at first, until you kind of see how to switch between one and the other. But for number one, we have three sides. It's a right triangle, and we want to know what's the tangent of A. So A is right here. And so if the point is A, then the angle is also called A, at least for triangles. If you have like more complicated stuff happening, then it might not be the case. But for triangles, the names of the angles are usually the names of the vertices if they give you the names of the vertices. So that's angle A. And the tangent, so if we use our little helper equation over here, so I'm going to use, let's do it over here. SOHCAHTOA. Right, so SOHCAHTOA. SOHCAHTOA. So we're going to use this part of SOHCAHTOA. And if you've never seen that word before, it's not really a word. It's more like something fun to yell out loud. SOHCAHTOA. But if you've never seen this before, it is a way to remember the three formulas for sine, cosine, and tangent, and a way to remember the way it's spelled is some old horse caught another horse taking oats away. Right? And there's a couple other ones, but that one's probably my favorite. So out of the three though, TOA, what do we do with that? In order to turn that into something useful, tangent of the angle, right? So tangent of the angle. And I like to use theta for an angle. It's a little Greek letter, but you guys might not use Greek letters. Not everybody does, but I like to, especially because it looks like a little pokeball. So tangent of theta is equal to the opposite side divided by the adjacent side. And that's how you turn those three letters into an equation. The first letter tells you which trig thing it is. S for sine, C for cosine, T for tangent. Then the other two letters tell you whether it's the opposite, adjacent, or hypotenuse being divided by the other one. So like SOH, sine is opposite divided by hypotenuse. So all of them are divided. They're all in that same format there. All right, but if you already knew that, then awesome. So we want tangent of A specifically. Tangent of A, which is the opposite side. Oh, we didn't label our sides yet, did we? So this is the hypotenuse. If the triangle is sitting flat on one of its bases, like if this were a real triangle and you actually like put it on the ground and it stayed there, then when that happens, the slanted side is the hypotenuse. The horizontal side and the vertical sides are the two different, just the height and the base, if you want to call them that. But those are the legs, and then the slanted side is the hypotenuse when it's like that. Okay, or it's just the angle that is across from the 90 degrees. Whatever works. So hypotenuse, and then the adjacent side is the other angle that's closest to the other side that's closest to the angle that we're talking about. Because technically the hypotenuse is sort of like close to the angle as well. But this side right here, being not the hypotenuse, we call that the adjacent side. Right? And then the other one is the opposite side. It's the one that's not connected to the angle at all. The angle uses two of the three sides of the triangle to happen, but the side that has nothing to do with how big the angle is, and in another way it kind of does, that side we call the opposite side. So OA, opposite is 30, adjacent is 16, and we can simplify that down a little bit because 30 and 16 both go into 2. So that would be our answer. All right, and that is how you do this. So for cosine, I'll go ahead and put sine and cosine in here so that we have our space. Sine is opposite over hypotenuse. But the one we're going to use for number 2 is cosine. Cosine of the angle is equal to the adjacent side over the hypotenuse. So the cosine of C, here's C, the cosine of C is going to be, here's hypotenuse, adjacent, opposite. The cosine of C is adjacent over the hypotenuse. Both of those divide by 3. Divide 12 by 3, I get 4. Divide 15 by 3, and I get 5. So that's the answer for number 2. Okay, so we talked about SOHCAHTOA so far and how to use SOHCAHTOA. So if you already know how to do that, then that's awesome. You're already a little bit ahead of the game. But the next thing we'll do, and I kind of already did this in number 1 and number 2, but I didn't really say what I was doing. I like to also write out a process for how to do these problems. So the steps. We're going to talk about the steps for number 3. So the steps that I'm using here are basically this. I want to, and if you saw the last couple videos that I put out that are in this series on Algebra 1 worksheets and stuff, using sine, cosine, and tangent to find missing sides or angles in a right triangle is normally done with these 3 steps. So I'm going to use one word, give you the short version, and then I'll add another word. But I like to start with the short version here. So that says label, and then pick, and then solve. Label, pick, solve, right? So I'm reading those out loud in case you can't read cursive, but cursive is nicer when I'm writing on a thing like this because, you know, it's less pen strokes. So label, pick, and solve. We want to label, specifically we want to label the sides. Right, so that's the next word that I would add if I wanted to add some more clarity to this. Label the sides, or just label sides if you want to take out the word the. Being real precise here. We want to label the sides. So we're dealing with angle Z. So sort of like a precursor step is to identify what angle we want to focus on. So I guess I can add that in as a step for number 4. But I'm going to just keep these 3 steps. I'm not going to alter them for number 3. I'll expand a little bit for number 4, but I'm trying to keep things real simple for number 3. Label, pick, solve. If you can remember that, then hopefully that'll help you to solve these out if you're having trouble. Okay, so label the sides. The hypotenuse would be this side no matter whether we're focusing on angle Z or angle X. But since we're focusing on angle Z, this side is the adjacent and the other side is the opposite. If I was focusing on angle X, it'd be the reverse. Like the 16 would be the O and the 12 would be the A. So that's why it matters. You have to figure out which angle we're wanting to focus on. So we did step 1, label the sides. Step 2, we want to pick, and specifically what do we want to pick? Right? We don't want to pick our noses. We want to pick the trig. We want to pick the trig, meaning what I was talking about earlier for number 1 and number 2. You have SOHCAHTOA, and you use SOHCAHTOA to help you to figure out which one you want to pick. So we already kind of have that done for us. So I have these steps specifically set up to help you to solve for anything related to right triangles and right triangle trigonometry. So that's why I'm saying like for number 4, I'm going to kind of hone in on some specific steps here. But pick the trig. Okay, well the trig is kind of already picked for us. It's sine. And then we solve. So we solve the equation. There we go. And so the equation that we would solve would be to just write out sine Z. Okay, and then sine is opposite over hypotenuse. 12 and 20 both divide by 4. That goes in that, and that goes in 5 times. So 3/5 is the answer. All right, so those are the steps that are more general. You can use those 3 steps: label, pick, solve. Label the sides, pick the trig, solve the equation. You can use those steps to solve pretty much anything in right triangle trigonometry. If you want to solve for a missing side or an angle or even just a ratio like we're doing here. But if you want a little bit more specific steps, then what we actually do first is we're gonna focus on which angle we're dealing with, right? So we identify the angle, so we mark the angle, I would say. Mark the angle. So we're dealing with angle C. So we just did step 1. Okay. Step 2, we do want to still label the sides. That is still something we definitely want to do. So we have to identify what sides we want to use: hypotenuse, adjacent, opposite. And then basically step 3 is once you've labeled your sides, you just, set up your equation. You don't really need to pick the trig, step 2, because it's kind of already picked for you. But like I said, the 3 steps, label, pick, solve, they work on everything. They're just not fine-tuned for this specific kind of thing. So mark the angle, label the sides, and then we simplify or plug in the numbers, basically. So plug in and simplify, I would say. Plug in. That's supposed to be a U. Plug in and simplify. Simplify Delos. Simplify. If you've maybe heard of that before, but you weren't sure what that was, Semper Fidelis is a Latin phrase that means always faithful. It's the slogan of the Marine Corps. Normally, it is shortened to Semper Fi, if you weren't sure what that was. Mark the angle, label the sides, plug in and simplify. So in order to plug it in and simplify, we are going to, let's see, plug in and simplify. We want to do sine. So I guess this is kind of like a step 2.5, is that we need to know what to plug in, right? So knowing what to plug in for step 3 is part of step 3. And sine is opposite over hypotenuse. So the sine of C is going to be the opposite side over the hypotenuse side. And both of those divide by 10 and simplify to 3/5. Okay, cool. So now that we've kind of talked about all the different things that you might need to know about all of this, we've pretty much got everything out of the way now. So SOHCAHTOA, what is that? How do you use SOHCAHTOA? What are some general steps? What are some specific steps? Done a lot of that. So at this point, that's pretty much everything that I can think of that you might need to know about how to solve these. The rest of them are going to be me solving them with less and less visible steps so you can see what it should look like as you progress on your journey to mastering this topic. So sine C, there's C, okay, and sine is opposite over hypotenuse. All right, so already I'm skipping a little bit of steps because I didn't label all the sides. I only labeled the sides that I knew I would need to use in order to solve the question. Both of these divide by 2. That's 25, that's 24, and there we go. All right, sine C again. Here's C. Sine of C, so we want to do opposite over hypotenuse. Right? Both of those divide by 2, but that's about it, because then we get to 7. 7's a prime number. Okay, cosine of A, and let's go ahead and change colors too. Why not? Cosine A. Here's A. So the cosine is 3. Or sorry, the adjacent side is 3. The hypotenuse side is 5. And that actually doesn't simplify. So we're done. Cosine X. Adjacent. Hypotenuse. So it's 24 over 30. Both of those divide by 6. And there we go. All right, cosine A. This one's a little harder because it's not sitting flat on one of its legs. It's actually sitting on its hypotenuse. If you have 2 slanted sides, then the slanted sides are the legs. and the flat side is the hypotenuse. Okay, so just keep that in mind because they will do that to throw you off. You can either like tilt your paper or tilt your face or do whatever you got to do. But just remember, if it is like this on number 9, then there's 2 tilted sides. So just be careful because it's more common that people miss the problem when it's tilted a funky way than when it's not. So just keep that in mind. There's A. So adjacent is 36 over hypotenuse is 45. The other way to check is to make sure that it's across from that 90-degree angle there. And there we go. I believe both of those divide by 9. That's 4/5. Okay, cosine z, here's z. Adjacent is 15. Hypotenuse is 25. Both of those divide by 5. And there we go. Sine z. Okay, so that's going to be opposite over hypotenuse. Both of those divide by 2 and 3, so it looks like 6 maybe is the biggest thing. You don't have to divide your fraction on the top and the bottom by the biggest thing, by the way. I just like to, so that way I'm not writing it out too much. But you could divide them by 2 and then divide them by 3 later. Not a big deal. So divide by 6, and I would get 3/5. All right, sine c. Here's c. So 36 over 45. Both of those divide. I literally just did this, I think. I did. It was 4/5. Look at that. A lot of overlap in some of these answers. Okay. And I would do yellow, but yellow doesn't show up very well, so let's just skip straight to like orange. So there's enough contrast that I don't have to try to change the thickness of the marker or something. Okay, x is right here. So we have 8/17. Tan A. Here's A, so we have opposite over adjacent, so 3/4. Here we go. Tan X. All right, so that's opposite over adjacent. Looks like 6, so 4/3. Oh, another thing too is that sine and cosine should always be a fraction that's less than 1. Tangent, though, can be a fraction that's more than 1. So if you get a fraction that's more than 1 for sine or cosine, that's a red flag. That means you did something wrong. You put something in the wrong order or whatever. But with tangent, you can have a number more than 1. So here's x. Opposite over adjacent. This one's less than 1. The other one was more than 1. It can go either way with tangent. But with sine and cosine, it should always be less than 1. Okay, so opposite over adjacent. Both of those divide by 5. And we get that. All right, and then we just have these last few here, and then you can see the answer. So they actually write the answer here as a decimal. I wrote mine as fractions. You can see that. We'll get to that in a second. Let me finish up, and then we'll talk about it. But you can write them so many different ways. When they say a ratio, really a ratio should be like a number and then a colon and then another number. But normally you write it as a fraction. This particular worksheet has the answers listed as decimals, but it's just up to your teacher. I would think, I'm assuming most teachers want fractions. If your teacher doesn't want a fraction, let me know. I'd be curious to know if your teacher doesn't like fractions for when you're trying to figure out like sine or cosine or whatever. Okay, so then it says use a calculadora, which I have right behind my computer. And when you turn that bad boy on, make sure it's in degree mode. Mine is in degree mode, so I'm good to go. Because we are dealing with degrees here, especially if you are taking like a geometry class. Maybe you're doing this worksheet, and even though the worksheet says it's Algebra 1, you're in geometry, because this is a very common thing to do in geometry, all this trig stuff. You might have to switch back and forth between degrees and radians every now and then. So just make sure before you do anything, because you'll get every answer wrong if you have your calculator in radian mode and you're typing in degrees. So sine 21, I literally am just going to type these in, and it says nearest 10,000th. Fun little side explanation here about the thousandths and all that is your decimal places are a little weird sounding sometimes maybe, but that's because right here every place is based off of this place. Every place is based off of the ones place. This is the ones. So if I have 10 of those, I know that's a little weird to put a 10 there because normally you would put a digit right there. But if I had 10 of that digit, right? So I had 0.1 and then I added 9 more 0.1s, right? So 10 0.1s. If I had that, then I would have exactly one ones place, right? I would have 1 if I had 10 0.1s. So because we're relating this place to that place, you call it the tenths place. A tenth, because it's literally a tenth. If you have 0.1, 0.1 as a fraction is 1/10. So it's called the tenths place because, each digit there is out of 10. It's a tenth. It's 1/10, 2/10, 3/10. It's hard to say that word really fast. And so then you start with tenths, and it seems a little weird because you're like, oh, wait, why would you start at 10? But it's like, no, you're not starting at 10. It's a tenth. It's a tenth of 1. That's why you start there. So when they say 10,000th, you just go backwards from tenths, right? So I kind of ran out of space here, but you would have tenths there, then hundreds here. So this one would be the hundreds. Hundredths, to be exact, but it's just hard to say that word. Tenths, hundredths, thousandths, and then tens of thousandths. It's really hard to say those words, so I normally just say thousands, but I don't mean to say it that way. It's just when you say it fast, it comes out that way. So 10, this would be the 10,000th place, aka 4 decimal places. So they could have just said that, but they like to be a little fancy sometimes. So 4 decimal places, but what that means is if we're going to round to the nearest 4 decimal places, then you use the 5th decimal place because you want to find out if it's closer to that digit or if it's closer to the next digit up, like standard rounding. Like if you have 6, it's like, is that closer to 10 or is it closer to 0? Well, it's closer to 10, so you would say that's basically 10. It's almost 10, right? Round up or round down. So anyways, with the sign, I just plugged it in, and it's 0.358. So now I'm on the 3rd digit. The 4th digit is a 3 on my calculator, but the digit after that is a 6. So actually, you know what? Let me write out several digits here. 3, 6, 7, 9, 4, 9, 5. I'm going to just write out all the digits my calculator gives me. Here's the digit we want to go to. So this number, is it closer to 0.3583 or is it closer to 0.3584 is another way to think about it. Well, it's closer to 0.3584 because of the 6. So we round it to 0.3584. And that is how you do that. Cool. So for the rest of these, I'm just going to, you know what? I don't even know if I'm going to type these in because literally you just type it into your calculator and they have all the answers in here, which I will scroll slowly through and show you, but they have all the answers in here. So that basically concludes the worksheet because there's not really any work to show for 17 through 22, and you can actually find the answers to these worksheets just by Googling them, which is pretty much exactly what I did. So if you just need the answers, you can just find that in Google. If you need to show work, there's not really any work to show for 17 through 22, unless you just did what I did for 17, but that's kind of overkill, I think. The other ones we can show work for. So anyways, here's the answers. If this has been helpful, of course, do me a favor and do the like and subscribe and all that good stuff. But I have a bunch of other content as well. It's not on YouTube. I try to put a bunch of stuff on my website, Myers Mathematics. I'm going to start putting basically whole books on there. But I'm going to start off with these worksheets with all the solutions, and things like that. So go check that out. I think on my main page there should be a little quick guide called the 5 math mistakes everyone makes and how to avoid them. So it's just a quick little guide. I'll give you some pro tips on maybe how you can quickly spot some ways that you might be missing math problems, no matter what math class you're in, and what to do to make sure that you don't do that in the future and correct course. So go check that out. It's on my website, myersmathematics.com, and I'll see you guys in another episode real soon.